Hello everyone, welcome back. In this video, we're going to be learning about how to create and modify the columns in our data frame. So let's begin with our standard imports of pandas and numpy. And let's go ahead and read in the data from the CSV file into our data frame. Same CSV as last time, all penguins, all day. Penguins equals pd pandas.read CSV. Name a file, which is Palmer penguins.csv. Alrighty. And as in last time, we're going to restrict attention to a subset of the columns. So we're going to say calls is equal to, let's get us species, island, Coleman length, that should be outside of the quotes, Coleman depth. Both of these are in millimeters. And let's not forget the region. All right, and we can say penguins is equal to penguins. That's just those columns. And now let's take a look at our penguins. Let's look at the first 5 rows by typing penguins.head. All righty. So here we don't have 17 columns. We just got 5. It's going to be a lot easier to work with. So the first thing we're going to learn how to do is to add a new column to our dictionary, to our pandas data frame. And the syntax here is going to look a lot like a dict. So in particular, we can make a column called Coleman length in centimeters by typing penguins, Coleman length cm. And this is going to be basically the same as our Coleman length in millimeters. But, okay, so centimeters are bigger than millimeters, so we need to divide by 10. And now let's take a look at our new data frame, penguins.head. So we can see this data frame looks almost the same as before, except we have a new column that also has the Coleman length in millimeters. And as you can see, that 39.1 millimeters is 3.91 centimeters. We can also add Boolean columns. These are particularly useful in a lot of applications. We've already seen Boolean indexing is just generally great. So we can say, for example, we can add a column tracking if the Coleman length is greater than 40. So we could say penguins, long beak. Let me just check my notes to see if I called it long beak. Maybe I called it long Coleman. Yeah, I was in a mature mood when I was writing this up before. Okay, we're going to call it long Coleman. I still prefer to call it the beak, but what have you. Okay. So penguins long Coleman is equal to penguins Coleman length in millimeters being greater than 40. And now let's look at penguins.head. And so now we have an extra column that is true, false, true, false, true, false, true, depending on whether or not the penguin's got a long beak or a short beak. For example, this guy right here, they got a 39.1, whereas this penguin over here, she's got a 40.3, and her long Coleman is true. So that's how you can add columns. Something else which we might want to do is we might want to try to learn how to manipulate the names of the columns. We already saw just a little bit of this, but now we're going to get a little bit more in depth. And we're going to focus in on something which is annoying about our data frame. Let's look at the penguin species column. Adelie penguin Pygoceles adelie. Gentoo penguin Pygoceles papua. And there's the other one, which was in the middle. I think it's like Dream Penguin, Dreamerist the bestest. I don't know. I can't remember the Latin name for the Dream Penguins. But point is this is long, it's annoying, and we should get rid of it. So what we're going to build up to over the next several examples is how to shorten the name of the penguin species to just being Adelie, just being Gento, or Dream. And the first thing we should observe is that the elements of this data series are strings, so we can use the functions associated with the string class, but not quite. So let's first try our first guess of pangs species dot upper, where you'll recall that the upper method is going to give us turns things to all caps. So this is not going to work. Series has no attribute upper. And that's because this is the issue. Right now we tried to call upper, which is a member function of the string class. It's a method of the string class on the series. But we want to call it on the string. So to do that, we type in str.str, and now we can use string functions. And now we get a whole bunch of super capitalized penguin species names. And if we want to just look at the first 5 rows, we can type in add in a dot head. So we can do penguins species.straw.upper.head. We get now this is in all caps. So all caps is cool, but what we want to get the first word. So to build up to this, let's get the first letter. So we do penguins species. And here the method of the string class we're going to want to use is get, and we're going to want to get the 0th index. But this is a method of the string class, so we have to type in str.get0. And now we get a nice penguin series of the first letter of each penguin. So we're on the right track, we're moving forward, but we don't want just the first letter, we want the first word. So what we're going to do is we're going to use split to split each row into a list of strings rather than a single string. So we can type in penguins species dot straw dot split. Okay, so now we got a list of strings, and what we want to do is we want to get the first entry of this list of strings. So we type in the same as before, penguin species dot straw dot split dot get 0. I forgot the str. If you just call the get 0, it calls the method of the list class. Yeah, that's a good point. Actually, we should dwell on. This was not a Mike is intentionally messing up to teach you things. This was a Mike accidentally messed up. However, this is a good opportunity to teach you something. Moment. So here, when you type this, we get the first entry of the list. And this is because we should pay attention to what sort of object we have here, which is here we have a list. So when you call it get 0, it gets you the first item of the list. But we don't want to do that. Instead, what we want to do is we want to use the vectorized get 0 operator of the string method to get the first letter of each string, first entry of each string. So when we do this, we now get Adelie, 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 Gento, Gento, Gento. And last but not least, we're going to replace the series column in our original data set with our new, much better series. So for this, we say penguin species is equal to penguin species.straw.split.straw.get. And now we can look at the first 5 rows of our new, much betterized data frame. All right. So the last topic here is externally setting columns. And so far, all the stuff we've done adding new columns has been like manipulations of the original data in your data set. But you could actually just define, you could just add whatever the heck you want to as a column, and it doesn't have to be related to your original data set. So one thing that we could look here is we can say penguins row number is equal to range lang penguins. And now let's look at penguins. And now we can see we added a new column that was just the row number. Something which is very important is that this does only work if this only works if the thing is the right size. So if we had said, instead of saying range lang pengs number, we had typed in, I don't know, 360, it's going to give us an error. So you can add columns however you want, but you need to make sure things match up. The one exception is if you're just trying to add a single entry to all of them, in which case you can use broadcasting. So we can say penguins row number is a platypus. And none of our penguins turn out to be a platypus, so we can set these all equal to false. And now look at our penguins data frame. And we can see that, lo and behold, if you have an entire constant value for the entire column, you don't have to make the size match up. So when you're adding columns, the size either need to be the same or the new column needs to have size 1, in which case it can use broadcasting. Also, unpopular opinion, I personally believe that penguins and platypuses are actually the same thing, but I've decided to teach you the prevailing wisdom, and I'm just going to briefly teach the controversy. There we go. Penguins, platypuses, same bird, heard it here first. Okay. Now another slightly less silly and also biological example would be to use reduction modulo 7. So we could have, what we could do is we could say penguins day of week is equal to penguins is equal to range lang penguins modulo 7. And let's see, is this going to work in one step? I might have to split this up into 2 steps. Yes, okay. So that's not quite how you do it. What we could say is we could say rows is equal to np.array range length 7. And then penguins day a week is equal to rows modulo 7. And we have to first convert this to a list. All right. Sorry about that. You have to be a little bit careful with the data types. As I did note that this is not something you typically will do, but what we now have created is we've created a new column that's going to go 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6. And this doesn't really make any sense in the context of penguins, but if you had a different data set that was like, you know, the number of people riding their bicycle on each day, this could be used to keep track of the days of the week. So not something to dwell too much on, but what you do is you create a list, or you create a NumPy array that is the right thing, and then you can just reduce it modulo 7, and then you get the days of the week. All right, that's it for this time. I will see you guys again next time.